this video, we go deeper into data wrangling using the tidyverse. So far, we've cleaned our dataset. Now we'll transform it in meaningful ways. We'll learn how to group data, compute summary statistics, and reshape datasets between long and wide formats. We'll continue using DPLR and introduce tidyr for reshaping data. In public health, we rarely analyze entire populations without grouping. We often want summaries by sex, age group, or exposure status. The combination of group by and summarize allows us to compute statistics for specific subgroups. To demonstrate the mean BMI by sex, we take the dataset n chains and then we use the pipe operator. The pipe passes the result from one step directly into the next step. It makes code easier to read because it flows from top to bottom. We group the data by sex using group by. This means R will split the dataset into groups, typically male and female, and perform calculations separately for each group. Then we use summarize to calculate a new variable called mean_BMI. Inside summarize, we compute the mean of the BMI column. We include na.rm equals true. This is very important as it tells R to remove missing values before calculating the mean. If we didn't include this, the result would return NA if there were any missing BMI values. The output is a small summary table showing average BMI for each sex. Next example, average systolic blood pressure by smoker status. This follows the exact same pattern. We group by smoker status, then we summarize and calculate the mean of systolic BP. Again, we use na.rm equals true to ignore missing values. This gives us the average systolic blood pressure for smokers and non-smokers. We can calculate multiple summary measures simultaneously, for example, mean, median, and standard deviation within each group. This is foundational for descriptive epidemiology. To do this, we group by sex again. But this time, inside summarize, we calculate three statistics: the mean BMI, the median BMI, and the standard deviation of BMI. The mean tells us the average, the median tells us the middle value when sorted, and the standard deviation tells us how spread out the BMI values are. By putting multiple calculations inside summarize, we can generate a more complete statistical summary for each group. Real-world datasets do not always come in the format we need. Sometimes variables are stored across columns. This is known as wide format. Other times, they are stacked vertically in rows. This is otherwise known as long format. Understanding long and wide data is very important in data analysis and critical for visualization and modeling. First, we create an example dataset called wide_data. It contains 3 individuals with an ID column. Then it has 2 BMI columns, BMI_2022 and BMI_2023. Each year has its own column. This is a classic wide format. Now we convert this wide dataset into long format. We use pivot longer from tidyr. We specify cols equals starts underscore with BMI. This means we select all columns that start with BMI. Names underscore 2 equals year. This tells R to create a new column called year that will store the original column names. Values underscore 2 equals BMI. This tells R to put the BMI values into a single column called BMI. The result is a longer table. Instead of 2 BMI columns, we now have one column called year and another column called BMI. Each person now has 2 rows, one for each year. This format is especially useful for plotting and statistical modeling. Next, we pivot back to wide format. We use pivot wider to reverse the transformation and spread values back across columns. We specify names underscore from equals year. This means the values in the year column will become new column names. Values underscore from equals BMI This tells R to fill those new columns with values from the BMI column. The result is a wide dataset again, very similar to the original one. This demonstrates how easily we can switch between formats using tidyr. One of the strengths of the tidyverse is the ability to chain operations together. This makes your code readable and reproducible. We start with n chains, then we filter the data to only include adults. Filter age greater than or equal to 18 keeps only rows where age is 18 or older. Next, we group by sex, then we calculate mean BMI for adults only. All of this happens in one smooth chain. Instead of creating intermediate objects, we simply pipe each step into the next. This makes the code readable and efficient. You can read it like a sentence. Take names, filter to adults, group by sex, then calculate mean BMI. In the next video, we'll begin exploratory data analysis, where we interpret these summaries and start generating insights from our dataset.